In the previous video, we covered the concept of heat energy. Heat energy is energy associated with temperature change and phase change. In this video, in this discussion on temperature and heat, we take a look at temperature change. Under normal conditions, under normal circumstances, an object increases in temperature when it gains heat energy and it decreases in temperature when it loses heat energy. In the previous video, we have noted that heat, capital Q, Q may be positive or it may be negative. By convention, heat gain, Q gain, is considered positive, whereas heat loss or Q loss is considered negative. And the heat associated with temperature change is given by Q is equal to C delta T is equal to MC delta T. So we have two equations for heat associated with temperature change. We have Q is equal to C delta T and Q is equal to MC delta T, where delta T is the change in temperature of the object. Delta T is positive if you have increase in temperature. So Q gain is positive, delta T is positive, the object increases in temperature. On the other hand, delta T is negative if you have decrease in temperature. Q loss is negative, delta T is negative, the object decreases in temperature. So Q is equal to C delta T and Q is equal to MC delta T. Capital C is heat capacity of the object. Unit is joules per Kelvin or joules per Celsius degree. And again, heat capacity of the object, this is property of the object itself. Each object will have its own value of heat capacity. Even if you have two identical or seemingly identical objects made up of the same material, object 1 will have heat capacity C1, object 2 will have heat capacity C2. M is mass of the object, and small c for MC delta T, small c is specific heat of the material. Unit is joules per kilogram Kelvin or joules per kilogram Celsius degree. Note that specific heat is property of the material itself that comprises the object, as opposed to heat capacity, which is property of the object. So, one is property of the object, the other one is property of the material itself that comprises the object. Water is a common substance. Preferably, you memorize the heat capacity, the specific heat rather of water. Specific heat of water is given at 1 calorie per gram Kelvin. So aside from joules per kilogram Kelvin, we also have calories per gram Kelvin. Seawater is 1 calorie per gram Kelvin or 4,187 joules per kilogram Kelvin. This is for water, liquid H2O. When water is in solid form, you have ice. The specific heat of ice is 2,220 joules per kilogram Kelvin. So again, take note, heat capacity is property of the object, whereas specific heat is property of the material that is comprising the object. Each object will have its own value of heat capacity. Each material will have its own specific heat. So you have specific heat of water, specific heat of ice. Air, again, is a common mixture. I will leave it up to you to look up the value of specific heat of air. So again, under normal conditions, an object will change in temperature. If you have Q gain, temperature increase. If you have Q loss, temperature decrease. And Q is equal to C delta T is equal to MC delta T. And under normal conditions, or generally speaking, when an object gains heat or loses heat energy, the temperature of the object will change. But under certain conditions, instead of temperature change, Q gain or Q loss will lead to phase change. And that's what we will look into in the next video. So that's it for now. In the next video, as mentioned, we will continue our discussion on temperature and heat. In the next video, we'll look into the concept of phase change. So once again, that's it for now. Thank you for watching.